Good day, everyone, and welcome to Introduction to Deep Learning. My name is Moeed, and today we will be talking about weights and biases. So, weights and biases is a tool for visualizing and monitoring the performance of your models, as well as keeping track of the model versions and their set versions. So, in the official website, they mentioned that they have 5 special usages. So, it's model experiment tracking, and reporting artifact, which relates to photo model and dataset versioning, tables for interactive data visualization, and hyperparameter sweeps. So we will be using some of, if not the majority of these during the course. It will be useful for you to look into them. So today we'll be talking about how to install and how to log into your WandB account from Colab or from any other Python interpreter. Um, how to do simple usage for it. So just logging up your experiment, how to do hyperparameter sweeps, what are they actually, and how to handle model versioning. So the first thing is you can go ahead from the website, you can create a new account. This account you created, just like create another account using Google or GitHub, or maybe just using your email. So after you create that account and you're signed in into your browser, first of all, you just download the library, just like any other Python library. Pip install WandB. Then these are some imports for the model for the live demo that we're going to use. And then you will just do WandB.login after you import it. You will be prompted to enter a web API key that you can access using WandB/authorize. After you get this key, you can just copy it from here. You can then just paste it, press enter, then you're logged in. But you can do another thing is you can paste it here and save it as an environment variable. So the next time that you want to log into WandB, you don't have to go through the entire setup where you have to go here and authorize. You're just going to use the same key. So looking into some of the helper functions that we have, you don't need to worry about most of these. We'll go through the ones that we need right now. You'll be familiar with most of this notebook by the end of the second homework. Basically, the task that we're doing right now is we're trying to create a model that will handle and learn how to classify images. So the places that we're going to look into are this train sweep function. We're going to look into parts of the training, the big training function. So when we're trying to use WandB at first, so if you're looking at a normal training procedure for any machine learning model, normally you will have a log like this. So you will have at each epoch, you will have a summary. So for example, our task was to classify images. So we have an accuracy and we have a loss, and we can sometimes also log the learning rate because we might use the learning rate scheduler to change the learning rate throughout training. So at each epoch, you'll have this summary. So this is good if you want to look at the end accuracy, but sometimes you would want to look into more things. For example, you want to compare a couple of experiments together. You want to check where were they at each time. So looking at just text data is not efficient. Another thing is you want to look at the trends for the model. So changing a few places in the model, how did that change the entire the performance of your entire pipeline? So the way you're going to do this, first of all, it's best practice to keep a run configuration dictionary stating what is the model that you're running right now, the type of optimizer, the learning rate, the batch size, and the epoch. So these three are some of the hyperparameters that you can change. Other things are related to the number of epochs that you run, and then depending on the task. But for this, we're looking to these three as hyperparameters, and then this is just the name and the number of epochs you want to run. So here we just load the data. Here we just load the optimizer, and then we create a new loss function and a scalar function just to help us out with running things more smoothly. So this is actually the weight and biases side of things. You will initialize a weight and biases run. You will create a project. If this project isn't already existent in your profile, then it will create a new one for you. You should specify a job type, and then you give the run a name. So here we're using the same name here from the run configuration file, so this will make it easier for you to handle. And then we will also like to save this entire configuration so that when we're looking at a run, we would want to figure out all this information about it, so we don't have to keep guessing. It's always good to keep track of information that you have. So then when we train a model, what will happen here is, as this model is training, this information about it, about a couple of things that we're going to see is being logged here. So this link will give you this run specifically, and it'll also give you a link to the entire project that we have, the WandB quick start. So if you go back to the training function, most of this you don't need to worry about right now. You'll be familiar with almost all of it after homework 1. But the main thing that we want to look into is that we have a training loss, training accuracy, and a learning rate that we got during training. So we want to save these. So what will happen is we'll create a dictionary, a Python dictionary for training loss, training accuracy, a learning rate, and then we will just do this line, wmb.log. This is after we have created the new run. So what will happen here is that these metrics, the training loss, accuracy, and the learning rate will be saved to WMB, and the way we can access it and visualize it is using this link right here. You can also access it from your main profile in WMB. So if you come here, you would see that this run, the first thing it shows you is the charts for you. So as you are going, it will keep logging. It's taking too much time to load, but it will load the training loss, the learning rate, and the training accuracy. So here, as we're going through, this is the first epoch, the second epoch, and the third epoch. Each time you have a specific value for the training loss and the training accuracy. But this is not the only thing. So here we have an overview of it, of this run. So you can see the status, who made it, is private or public. We can add tags to it. We can have a link to the collab notebook for it, and then a few things that we're going to look into later. And then this is the configuration file that we have. So we have the batch size, the number of epochs, the learning rate, the name of the model, and the optimizer. And this is at this moment in time. What's our learning rate, what's our training accuracy, and what's the training loss. So these are the things that we decided to log. Even more important than that, we can look into a couple of other runs together at the same time. So if we look at here, we can see that I've already made 3 runs. So, and like using a different configuration for the model. So 3 and 2 and 4 CNNs together. Here we can see that we can compare the performance of them, each of them at each epoch. We can see which one is performing better, which one is performing worse. And then we can also look at the loss, and then here the learning rate is all the same. So this way, using these 3 lines of code, or basically it's just 1 line of code. So you define the metrics and then you log it. And then as you change different things throughout your model, you can have access to these metrics, and you can compare easily different runs together. So let's stop this, because as you can see, even if I come out of this, or if I have a machine running on AWS, instead of just looking at these logs right here, I can go and check out how is the run going here, and then maybe also I can check out like this run. I can have also access to the overview again, to the link to the notebook, etc., etc. And then I can have access to its logs. So these are the same logs that we have here. So I could look into all of them, what happened, and at the end, the model that I ran. So this is for the specific run. Let's stop out of this so I can go ahead. The next thing that we want to look into is hyperparameter sweep. So hyperparameters are things in the model, are values on the model that we set on our own, and we change independently, so we don't have to learn. So when you have a machine learning model, you have some parameters that you learn, which are basically the weights and biases of the model, and then you have other things that you don't learn. So what happens is, if you're running a model, these things you have to take by yourself. You have to decide, maybe guess sometimes, or maybe do some sort of search to find the best hyperparameters. So these include, like we mentioned, the learning rate, the optimizer, and the batch size, maybe the number of epochs, maybe other things relating to, you know, what sort of task it is. So here, in the documentation for WMB, you can have much more explanation of everything that we're going to go through. But here, we're going to look into a few normal things. So the first thing that you do is you create a sweep configuration dictionary, and then you specify the method for your hyperparameter search. So it's either a grid search, where you search through each and every single value, It's either a random search where every time you choose a random value, or you can choose a Bayesian search where the probability of selecting a value depends on whether it performed well in the last time or not. So more or less, you're gonna go through with random. You can look into these other two in the documentation also. It has some good explanation on it. The other thing is you specify which metric are you using. So here, maybe you want to minimize a loss, or you want to maximize an accuracy, or you want to minimize the distance, or you want to maximize whatever you want to do. You're just gonna write it here and specify what is the thing that you wanna keep as a metric and what's the goal, and then you save it to the sweep configuration. And then we come to the actual parameters itself. So you define a parameter dictionary. Each parameter you have to specify the values that it's gonna take. So the first parameter is an optimizer. You have to choose between SGD and Atom. So we do values, and then we put the values that we're gonna choose between. The next one is the learning rate, and then we have a uniform distribution for the learning rate between 2e minus 4 and 1.1. And as you go through the sweep, every time you will choose a value uniformly distributed over this range. And then you have batch size, which we choose to be a Q log uniform distribution. So this means that between 16 and 80 and 128, every time we're going to choose values as the increment of 4. So you start at 16, maybe next time you will choose 20, 24, 28, etc. as you're going through. And the last thing is the number of epochs. Here we don't need to, you can set it also as different values or in a range, but for our case, we know that, for example, in some models later down the line, you'll know that your model will converge after, for example, 10 epochs. So you want to compare your models after, for example, 12 epochs to see the effect of changing these values on it. So because it's a single value, we'll just set it as value. And then at the end, we'll add the parameter dictionary to our sweep configuration. And then we would need to initialize a new sweep. We give it the sweep configuration that we've been setting up. And then we need to give it a project. Then WandB will also again give us a link to that sweep, and then it will give us a sweep ID. Then we will use WandB.agent to run the sweep ID. And then we run the train sweep function. We're going to look into in a bit. And then count is how many times do we want to run this. So how many sweeps do we want to run? So what we mean by sweep is a set of parameters. So first time, for example, you use SGD and 0.01 as a learning rate and 64 as your batch size. And then the second time you use different sets of hyperparameters. So here I said that you're going to use 5 hyperparameter combinations. So when we run this, it will start. Each time it will tell you the parameter combination that it chose, and then it will run the model for here we specified 5 times. So if you want to go back to the train sweep function, right here, it takes the configuration file. In our train loader function, we know from above that it takes batch size and then some data files. So each time we give it a different batch size coming from the configuration file. We create our model. Our optimizer takes an optimizer name and a learning rate. So these also come from the configuration file. Anything comes from the configuration file is set up by the sweep. So these 3 have different values each time we run this train sweep function. And then we define our scalar and loss again. And then going through the number of epochs that we specified, we're going to train our model through the train epoch function. It's basically the same as the training methodology, but the big training function, but it doesn't have the logging part for it. So this is what will happen. It will go through it 5 times, each time logging to WandB the loss. So if we come back here to our sweep function, we go to this link. So it will show us that sweep specifically. Here we will have a chart of the loss that we decided to check. So let's ignore this one. And then each time it will give you a specific sweep. So here, this one, it took batch size 64 and this learning rate and Adam as an optimizer, and then the loss was 2.0. For different sweeps, we have different values. So to look at this more concretely, let's look at another sweep that I ran for 100 times or 100 combinations. At the end, you'll have something like this. So you'll have each sweep will have a different loss curve. Here you'll have your functions. Each time you want to see like which sweep performs the best. Here you have importance and correlation between each of the hyperparameters and the loss that you got. And this is the other thing that you want to look into is each one of these lines is a sweep, independent sweep. So if you look into this one, this is starting at a lower batch size and a lower learning rate and using SGD, and we'll see that where it performed. So what you can do is you want to look into, for example, the least loss and check out its hyperparameters, or maybe you want to check out other trends. So for example, you want to check these low performing or good performing models, what's the common factor between them? So if we look backwards, the optimizer doesn't really matter. The learning rate is quite also doesn't matter, but looks like if you want to use SGD, you have to have a higher learning rate. If you want to use Adam, you have to have a lower learning rate. But the most common thing is that you would want to use this relatively smaller batch size. So these are the things that you want to look into when you're doing hyperparameter sweeps. And this sweep will continue every time you will see a run. You will see a run, and then you will see its related values for each sweep, the loss values, etc. So if you go back to our original sweep, you will see that it kept running and gave us a couple more values and a couple more sweeps and values for it. So these two seem to be performing well. Yeah. So this goes on until you finish up the five sweeps that you have. And the last thing that we want to look into is artifacts and model versioning. So after we finish with the sweeps, we found out from the previous one that this is the best combination of parameters. We'll then do our normal model initiation, and then we can train our model. At the extra thing that we didn't look into in our train model function is this updating the model version part. So what will happen here is that we would want to save our model if it performs better than the previous model or perform better than the best model that we have. So each time we're going to compare our new accuracy with the best accuracy that we got. We're going to say if that's the case, if it's better, we're going to save that model. So instead of saving the entire model file, we're going to use save the state dictionary for the model and optimizer, and maybe also for the scheduler if you're using a learning scheduler. Then we'll create a new artifact. We'll give it a name. So the same name as the model, and then we're going to give it its type as model. This can also be vary the type. You can look into the different types. Maybe you want to save a data set, and then we would add the file that we just saved. You would want to add the model file, and then you would want to log that artifact using the same run file that we got from initiating our run. So what will happen here is that every time that we would make a new run, going through that run, if the model is better than the previous model, then that means that we're gonna save that model. So if you look into this specific run that we just initiated, coming through here, we look at the overview, we look at the charts. You can also look at the system. It will show you the CPU and GPU utilization and memory utilization and other things relating to how the model performs. This can be helpful, especially the GPU utilization part, because you might run into out of memory errors like we mentioned before. You can look at the logs. You can look at the files. So the files are artifacts, configuration files, and the output files. But then you can look at the artifacts. So here you can see that each time the model is saving a newer version, and this version is the one that we can retrieve. So how do we retrieve this? So let's say we train these models, and then we would want to we have another teammate on our run, and they want to load this, so they can access the same notebook, and instead of starting from the bottom or starting all over again, they can just reuse and load the same file. So what will happen here is I will have the name of our version of the artifact or the model, and then .latest. It will give me the latest version. Then I'll download that artifact, And then because this is a PyTorch file or PyTorch dictionary, I would load it using torch.load. This is just a path to that file that we just downloaded. And then I can load both the state dictionary for the model and the optimized state dictionary just normally. So if you look at here, this is a common issue that you might face if you stop and start WandB runs without properly finishing a run. So if you see something like this, you can ignore it. It doesn't affect the running of the of whatever code that you're running, but it's best that, like if you see here, you would have a backend shutdown process for WandB. It's best that you use this WandB.finish after each time that you create and finish up from a model. So here, what we would have done better is at the end of this whole training function, we would add WandB.finish right here, and this will allow us to stop the WandB process and not cause it to crash for us. So that has been all. Thank you very much, and I hope you enjoyed this and you can benefit from it further on. Thank you.